Welcome! In this video, we will cover angles on quadrilaterals. We will discover properties of most commonly known quadrilaterals and solve geometrical problems involving those shapes. As a prerequisite to this tutorial, please visit my other video on angles on triangles and parallel line angles if you haven't already done so. Before we move on, please support this channel by clicking like, share and subscribe button so that you don't miss out on any one of my latest tutorial videos. Your support will go a long way and help others who really need this support. If I give you 4 of these lines and ask you to make a closed shape, what kind of shape can you make? One of the shape you can make could look like this. This is known as quadrilateral. Lines of the quadrilaterals meet at a vertex. If one of the line was to be drawn from one of these vertex to connect another vertex which is not already joined by a line, then this creates 2 triangles. We can always divide quadrilaterals into 2 triangles this way. Since the angles of each triangles add up to 180 degrees, angles on any quadrilaterals is twice that amount, which is 360 degrees. These lines are equal and 2 pairs are also parallel. Arrows on the line are used to denote the lines that are parallel. The lines with a single arrow is a parallel to the one with a single arrow, and the line with a double arrow is parallel to the line with the double arrow. If I give you these lines, what kind of closed shape are you able to make? One of the shape you can make would be a square. Squares are one of the most special quadrilaterals of them all. All sides of these squares are equal and meet at a vertex. Opposite sides are parallel and they have 90-degree angle at each vertex, and the total angles of the interior angle add up to 360 degrees. If we connect 2 vertices which is not already joined by a straight line, we can now draw 2 diagonals on a square. They meet at the center of the square and also have equal lengths. Diagonals bisect each other and each half of the diagonal is equal to the other half. And also these diagonals meet at 90 degrees. Given these lines, you may also make a rhombus. Rhombus basically is a square which is leaning on its side. They could lean to the right like this, or they could lean to the left like this. They therefore have the similar properties of a square, but angles between its sides are not going to be 90 degrees. Rhombus has all the sides are equal and opposite sides are also parallel, just like this square. Opposite angles are equal and the total angles also add up to 360 degrees, just like any other quadrilateral. Their diagonals bisect each other and meet at 90 degrees, just like on the square, but diagonals are not equal to each other. Now suppose you are given 2 pairs of equal and parallel lines. Then, using these lines, one of the shape you can create is a rectangle. This is one of the most common shape in mathematics. Opposite sides of the rectangles are equal and parallel. They also make 90-degree angle with each other. And their diagonals are equal and bisect each other. It's also possible that you can make a parallelogram with these 4 lines. Parallelograms are basically a rectangles leaning on its side. If they lean to the left, the shape might look like this, and if they lean to the right, shape might be looking like this. Parallelogram has opposite sides equal and parallel. Opposite angles are equal and all angles add up to 360 degrees, just like any other quadrilaterals. And diagonals of parallelograms are unequal but bisect each other. If you are given 2 pairs of lines which are not parallel but equal, you may be able to make the shape like this or like this. This is a kite. Kite is another special quadrilateral. They have two pairs of adjacent sides that are equal. Only one pair of the opposite angles, which are created by two unequal sides, are equal. Since kite is also a quadrilateral, all the interior angles add up to 360 degrees. Longer diagonals bisect the shorter diagonals in half, and diagonals meet at 90 degrees. There are only one pair of sides that are parallel in this diagram, which has been marked with an arrow, and all the lines are unequal. We are able to create a trapezium using these four lines. One of the trapezium could look like this. Or you can also form the shape like this. Trapezium has one pair of parallel lines. Diagonals are unequal, but they intersect each other. Two adjacent angles formed by two parallel lines and one other line add up to 180 degrees. This is because these two angles forms the supplementary angles, and all the angles on trapezium add up to 360 degrees. Similarly, we can make an isosceles trapezium with four of these lines, where one of the set is parallel pair and other pair is equal sides. Isosceles trapezium could look like this or like this. Isosceles trapezium have a pair of parallel lines just like the trapezium, but they also have one pair of equal non-parallel sides. In this example, we would like to find the angle BAE, and ABCD is a parallelogram. Note that these angles are not drawn to scale, so we cannot answer this question by measuring the angles with the protractor. Opposite sides of the parallelograms are parallel. Therefore, we can use the parallel line angles to find the missing angle. On this occasion, the angle BAD and ABE are equal, as they are alternate angles. Therefore, angle ABE is the same as angle BAD, which is 128 degrees. Angles on a triangle ABE add up to 180 degrees. Therefore, we can find the angle BAE by subtracting 128 and the given angle 39 from 180 degrees. This gives us 13 degree. In this question, we are given ABCD is a parallelogram, and also two angles of size 75 and 35 degrees are given. We need to show that the angle ABF is 70 degrees using those information. First of all, the angle DCB and BAF are both 75 degrees, as the opposite angles of the parallelograms are equal angles. Angle AFB and EFD are also equal angles, as they are vertically opposite angles, and they are always equal too. Angles on a triangle ABF add up to 180 degrees. Therefore, the angle ABF can be found by subtracting 75 and 35 from 180 degrees. This gives us 70 degrees. In this example, ABCD is a parallelogram. Therefore, opposite sides of this shape is equal and parallel. This means you can use parallel line angles to connect the given angles to the angles that we wish to find. In this case, we are after the unknown angle x. Angle EBC and ADE are equal angle, as they make up the alternate angle together. Angles on triangle ADE add up to 180 degrees. Therefore, angle AED can be found by subtracting 25 and the given angle 63 from 180 degrees. This gives 92 degrees. The angle ADE and AEB also lie on a straight line. They add up to 180 degrees. Hence, the value of x can be found by subtracting 92 from 180. This gives the value of x as 88 degrees. The kite is the only quadrilateral with two adjacent sides equal and one opposite angle equal. In this example, AB and AD are two adjacent sides of the quadrilateral ABCD, and they are given to be equal. Therefore, we just need to show one opposite angles are equal in this quadrilateral to show that this shape is a kite. Angle ADC can be found by subtracting 75 from 180 degrees, as the angles on a straight line add up to 180 degrees. This gives us angle D as 105 degrees. Angle BCD is vertically opposite to angle 50 degrees, so it is also 50 degree. We can now find the angle ABC by subtracting the angle 100, 105, 50 from 360 degrees, as the angles on all quadrilateral add up to 360 degrees. This gives us 105 degree. This is equal and opposite to the angle ADC, therefore the quadrilateral ABCD is a kite.